Hello everyone, myself Sowmya, Assistant Professor in CSE AIML Department, MLR Institute of Technology. In this video, we are going to discuss about overview of blockchain. So coming to the overview of this presentation, this presentation covers what is a blockchain technology, so history behind this blockchain, and what is consensus mechanism, what are the different characteristics of blockchain, what are the different disadvantages of blockchain and different applications of blockchain. So all these things we are going to discuss in this video. So first of all, what is blockchain technology and why we are using this? So nowadays everywhere, wherever we see a different application, so they are using blockchain technology, and they are saying that the main motto of this blockchain technology is to secure the data. So what is this blockchain technology and how it will secure the data, that we will discuss here. So we have a formal definition for blockchain technology. So blockchain technology is a decentralized and distributed digital ledger that records transactions. So we know ledger, in banks or wherever we go, they will maintain a ledger of accounts, right? So all the records or all the details of the customers or anything, they will maintain in terms of ledger. But here it is maintaining a digital ledger. So it's not a hard copy, it is a soft copy, that is digital ledger, and distributed and also decentralized. So what is the meaning of this decentralized and distributed? So here we have a picture to explain this centralized and decentralized. So till now, whatever the applications we are using, like client server applications or whatever it may be, so everything is centralized. Centralized in the sense we have a central server and all the clients, all the systems will be connected to that central server. If any system wants to do some action like opening a file, closing a file, whatever it may be, it needs to take the permission of this server. So if the server says okay, then only it can access that file. So that is the centralized. So if server is busy, then the remaining systems or the remaining clients has to wait. And one more problem is, if the server fails, what happens? We have only single server here. If server fails, what happens? And everything, the complete data will be maintained at the server only. If the server fails, where's the security for that data? So this problem is called as single point of failure. So this problem will occur in the centralized server, centralized system. So where we use a centralized server to give the permissions to all the clients. Whereas in the decentralized, so here all the clients or all the systems are interlinked. There is no centralized concept here. If we observe in this figure also, there is no central server. So each and every client or each and every system has equal responsibility. So they can take the decision, right? But what about this data? So the data also distributed, right? So here, of course, in the decentralized, everyone has equal rights to take the decision about the data deletion or inclusion, whatever it may be. But what about the data at each system? So that is fulfilled by using this distributed ledger. Distributed ledger in the sense, whatever the data it is maintaining in the server, in the centralized, the same copy will be distributed to all the nodes in the decentralized and distributed system. So these two things, both the things can be achieved by using this blockchain. So blockchain technology is a decentralized and distributed digital ledger. So decentralized in the sense there is no central authority to take the decision. So everyone has equal right to take the decision. And coming to the distributed, so the copy of the ledger will be maintained at the each source, each client or each node. So what's the use of this? Because even if this one node fails, then the same copy will be available at the other nodes. But if we go with the centralized, there is a problem of single point of failure. If there is a problem with the server, single pointer, this is the single point we are considering here. If there is any fail in the server, then the remaining clients may not access the data. Why? Because only the server is maintaining the data. But whereas in distributed ledger, each and every system will work as a client or node, and every node will maintain a ledger copy. So that even if one node fails, the other nodes will maintain the data. So these are the two main advantages or features of blockchain technology. So where it will provide, there is no single point of failure in the blockchain technology. And coming to the other definition of blockchain. So a blockchain is a chain of blocks where each block contains a list of transactions. So we know, like, everyone is using blockchain for two purposes. So one is for security and the other for there's no single point of failure. So these are the two things. So this point we covered in the previous slide. And coming to the security. Security, for example, if I have some data, if someone is trying to modify data, so the hacker has modified the data, but I don't know where he has modified. So when he has modified, why? Because there is no change in the transactions or data. So that's why I'm not able to identify where the problem is or where the updation is. But whereas in blockchain, it's not possible to hack the data or it's not possible to modify the data. So in such a way, they are creating this blockchain. So we'll see this blockchain is nothing but chain of blocks. So what is a block? So here this is one block, this is one block, and this is another block. So like this, all the blocks will be connected through a chain. So how these blocks will be interlinked? If we observe here, each block will maintain all this data. So what is the data? It's a block number. Then what is the data it is maintaining? Data is nothing but transaction. So what are the transaction we are including in that block? And previous hash. So we have the current hash as well as the previous hash also. So hash is nothing but it's like an address. We are providing a uniqueness for the block using hash code. So for generating this hash code, it is using SHA-256. Secure hashing algorithm to generate the hash value. So hash is nothing but it is a code, it is a unique code, right? So once if you use this code, this will not be repeated for any other block. So if I give some data hello, for this using this algorithm, it will generate some hash code of 256 bits, right? So this is a unique value. Now if I give another code, I will get another hash code for this. So like this, for each block, a hash code will be associated to provide some uniqueness for that block. Then how this hash code will be used or how this hash code will be generated? So to generate this block 1 hash code, it is using the previous hash value. So to generate this hash value, current hash value, it is doing some operations, but along with that, what it needs, it also needs the previous hash value. For example, if there is a change in the data, I told you already, if hello, for hello, we have some hash code. For bye, we have some hash code. So now I have some hello. For this, we have some hash code. Now, if I add a character here, obviously, automatically the hash code will be modified, will be changed. Why? Because here I have one more character, then the hash code, the complete hash code value will be changed. So now, if I calculate, if I modify, if any hacker or any middleman modifies this data, automatically the hash value will be changed. So there we can easily identify there is an attack, the attacker has modified the data. But before attacking, we cannot modify this data first of all. Why? Because it is immutable. So blockchain ledgers are immutable. So once you write the data into the block, we cannot modify it. So this is only write once. We can't edit that. If you want to add some properties for that block, you need to create one more new block. So you can't edit that. If you want to add some properties, then you can create one more block for that. So that is the use of this hashing. So while calculating the current hash, it will also link with the previous block. How it is connecting to the previous block? By using the previous block hash code. So for calculating the current block hash, it is using the previous hash. Now if I want to calculate the block 2 hash, it needs the previous hash value. So if I know the previous hash value, then only I am able to calculate the current block hash value. But coming to the first block, so which is called as Genesis block. The first block in any blockchain is called as Genesis block. So for this, we don't have any previous block. So that's why the previous hash will be 0. So using this, it will calculate the current hash. So along with these details, data, previous hash and the current hash, along with these details, it will also maintain the timestamp. So when the user has created this block, at what time and the date, everything it will maintain as a timestamp in the block. So like this, the collection of blocks will be linked together and this block chain of blocks is called as blockchain. So how we are linking all these blocks together? Using a hash code. So each block will contain all these details. The first one is hash of the block. So it is nothing but it is an alphanumeric number to identify the block. It is a unique number to identify a block. We are using this hash. And hash of the previous block. So we are also maintaining the hash of the previous block, and this will be used to calculate hash of the current block. And timestamp, so when the block is created or when the transaction is added to the block. Then is nonce, so it is a random number used to vary the value of the hash. So we know hash is used to provide uniqueness for the block. Just to add some more uniqueness for the block, you are also creating nonce. Nonce is also a random number which will provide uniqueness for your block along with the hash code. And next is Merkle root. So hash of all the hashes of all the transactions in the block. So for example, I have 10 transactions in a block. So this is completely one block. In this I have some 10 transactions. For each transaction we have some code, hash code, 256-bit hash code. For example, I am taking 5 blocks, 5 transactions here. So by combining all these 5 hashes, again I am generating one more hash, and that is called as Merkle root. So Merkle root is nothing but hash of all the transactions in the block. So next is transaction data. So what are the transactions you are adding to that block? Those details will be available in the block. So these are the main details which are maintained by each and every block in the blockchain. So coming to the history behind this blockchain. So when this blockchain has come into the picture, and what is the route for designing this blockchain? So in 2008 actually it came into the picture, but the concept of this blockchain, it was available in the 90s also. So in the later on videos we will discuss about that, but here in October 2008, individual or group. So why we are mentioning as individual or group, they use some anonymous name. So pseudo anonymous name they used. So what is that anonymous name? Satoshi Nakamoto. So till now we don't know the identity of this person. We don't know even it is a single person or a group of person. They gave some anonymous name for that. That is Satoshi Nakamoto. So that's why we mentioned as individual or group. It may be an individual person name or it may be a group name. They have given a group name for the set of developers. Right, so they published a white paper, and the title of that white paper is Bitcoin, a peer-to-peer electronic cash system. So the main motto of this white paper is to transact, to transfer money from one account to other account without any additional charges. For example, from account A to account B, if I want to transfer from 2 lakhs or 5 lakhs, then it will charge some amount. So if the amount is more, then obviously the additional charges will also be more. So to overcome this type of additional charges, what we need to follow. So all those techniques will be available in this white paper. So not only this, if I want to transfer some amount to international account, so one country to other country, then obviously the charges will be more. So to overcome that problems, so Bitcoin, it is a cryptocurrency. So it is not actually a normal currency, it is a digital currency. Bitcoin is the first cryptocurrency which used blockchain. So actually in this paper they have mentioned about the Bitcoin. In that Bitcoin, to develop that Bitcoin or to design that Bitcoin, they used a concept of decentralized digital currency. So decentralized in the sense there is no central authority. For example, if I want to transfer some money from account A to account B, then I will raise a request. So this request will reach to the bank server. Then bank server will accept this and it will transfer the money to B. But in this process, we have so many steps. It will check whether the amount is available in the A or not, how much amount it is transferring, whether I need to charge for this transaction or not, right? So all those details will be done by this centralized server, that is a bank server. But here in the Bitcoin concept, we don't have any centralized authority. So why? Because it is using decentralized digital currency. So there is no central authority. So everyone in the blockchain or everyone in that community has equal right to take the decision. So that is the concept of decentralized digital currency. So it is actually a digital currency, Bitcoin, which used the concept of blockchain. But at that time, so whenever he wrote this paper, at that time, he didn't mention about the blockchain, but he mentioned only about the topic or the feature decentralized digital currency. So later on, it came into the topic blockchain. So which will also follow the same technology, that is distributed and decentralized. So here we need to observe the difference. So Bitcoin and blockchain, both are not same. So many people will confuse. If I say a word blockchain, yes, I know blockchain, it is a Bitcoin. So it's not a Bitcoin. Bitcoin is different from blockchain. Blockchain is a technology and used by this application Bitcoin. So this is one of the application of blockchain, but Bitcoin itself is not a blockchain, right? So blockchain is a technology which supports distributed and decentralized ledger of records. So the application of this blockchain is Bitcoin. So like this Bitcoin, we have so many digital currencies which supports this blockchain, like Ethereum, Namecoin, Peercoin. We have so many other digital currencies also. In the later on, after 2008, later till now, so many digital currencies are there which are using this blockchain technology. So next is consensus mechanism. As we know, there is no single or centralized authority here to take the decision. Then how it will work? If the individual is taking the decision, then how it will work? Then who will validate the transaction? If I want to insert a transaction which is not valid, then how it will accept the transaction? How it will validate the transaction? To perform that thing, we are using a mechanism called consensus mechanism. So what is meant by consensus? The transactions are verified and added to the block through a process called consensus. So a block is nothing but it is a collection of transactions. Then how you are adding the transactions to that block? There should be a validation process. That validation process you are calling as consensus. So to perform this consensus, it involves network of computers and reaching an agreement on the validity of the transaction. So we have some set of nodes. Each node has to vote whether the transaction is valid or not. For example, I have some 7 nodes here. If I get minimum of 4 votes as valid, then I can consider the transaction as valid. So why I'm saying 4 nodes here, in the sense we have totally 7. So minimum I should get 51% of voting. Right? So if I get minimum 51% of voting, then I can consider that transaction as a valid transaction. So here, once a block is added to the blockchain, it is extremely difficult to alter or tamper with the information contained within it. So in the previous slides we discussed, so if I change any, if I do any change in the transaction data, the block address or the transaction hash address will also be automatically changed. With that, we can easily identify where the data is tampered actually, but it's not possible as the blockchain is immutable. It contains an immutable ledger. That means once the data is added to the blockchain, we cannot modify that. We cannot alter that. And we have different consensus mechanism based on the requirement of blockchain. We can use different mechanisms. So the first one is proof of work, proof of stake, and delegated proof of stake. We have others also. We have so many different types of consensus mechanisms. In the later videos, we will discuss in depth about this. But what is consensus? It is a mechanism to validate a transaction. So this is a consensus mechanism. So this is the transaction we have, and these are all validators or nodes. So how many set S? 1, 2, 3, 4. So 4 set S and 2 set no. Then I should take it as a valid transaction. So this is a valid transaction. Why? Because majority of the people are saying the transaction is valid. So that's why I can say valid. So how they will say blindly, can they say a valid transaction, it's a valid transaction? No, we have some process for that. In the consensus mechanism, we have some process for each and every consensus. For POW, we have some mechanism. POS, proof of stake, we have some mechanism. So by doing that process, only they can validate the transaction. We will see that in detail later. So what are the different characteristics of blockchain? So we know the first one is decentralization. That means there is no central authority to take the decision. Everyone has equal authority. And transparency. So basically blockchain is transparent. That means the transactions are open. Everyone can see the data. Why? Because we know no one can tamper the data. No one can alter the data. But they can see the data. It is transparent. And next is security. Each transaction is encrypted and linked to the previous transaction, forming a chain of blocks. We know there is no possibility of modifying the transaction in a blockchain. So in that way, it will secure the data. So why I cannot modify the data? If I modify the data, automatically the hash code will be modified. and the hash code of the rest of the blocks will also be modified. Why? Because the hash code, to calculate the hash code of this block, I need to depend on the previous block. So if the previous block address is changed, automatically the remaining rest over blocks address will also be changed. So that's why it is very secure to use the blockchain. And next is immutable. So once if I add any transaction to the block, I cannot alter that or I cannot modify that. So next is smart contracts. So smart contracts are nothing but it is a programming code which is used by the blockchain. So they automatically execute actions when the conditions specified in the contract are met. Smart contracts eliminate the need of intermediaries and enhance the efficiency in various industries. For example, I want to transfer some amount from account A to B. So generally, if I use a normal traditional banking, some person should be there to check that. So whether he is having some sufficient funds or not, can I transfer the funds to B or not? So like this it will happen. But if I write a smart contract for this, so I want to transfer from $50 from A to B, then what smart contract will do? It will check the balance of A, whether he is have minimum of $50 or not. So if the condition is true, and if the request is raised, then automatically the dollars will be transferred. Not only for this, for example, we can take landlord. So I want to buy a land from a person A. So the person B wants to buy a land from A. Then what person B needs to do? He needs to go to the registration office, municipal office to check whether the documents are valid or not. Why? Because nowadays so many like illegal properties they are selling, right? So the person B has to verify whether the documents are valid or not, really whether it is a trusted person or not, right? So he needs to go to the different offices and search for different things, right? Then if it is valid, then he needs to pay the amount and the documents he need to transfer onto the B. This is all it's a lengthy process which may take 3 months to 6 months based on the land, right? But if I use a smart contract, so in the smart contract, the person A will update all the land documents. So smart contract automatically will check whether the documents are valid or not by considering some conditions. So we know smart contracts are nothing but it's a programming code which execute the actions based on the condition. If so and so condition is true, then the document is valid. In that way, the smart contract will verify. So if the verification is done, then if A is willing to send the land to B, then they will make an agreement in the online itself and automatically the credentials will be transferred to the B. So this is all the automatic process which can be done using the smart contract. But we should be very careful while writing the smart contracts. Why? Because this is all dealing with the high amounts, right? So for this type of examples or landlord or whatever it may be. So we should write carefully while writing the smart contract. So to write a smart contract, to verify the document, we need to consider so many parameters here. So all those parameters you need to include in the smart contract code. But that's the use of smart contract which we can make the process automatic. Right? So whenever a specific condition is true, the action will be done automatically. So we have some disadvantage for blockchain also. So first is scalability. So blockchain is decentralized and distributed ledger. So each and every node will maintain a copy of the ledger so that the more memory will be wasted to maintain the multiple copies. So there we will get this scalability issues for the large scale applications. And next is energy consumption. To develop this blockchain applications or to perform this consensus mechanism, we need high-end systems and which will use more energy consumption. And next is adoption. So as blockchain technology is a new technology, so no technical persons are there. No technical. So we have only less number of people who can adopt this technology. So already we are going with the existing technology. We should able to adopt to this new technology by learning all these new things. And lack of standards. So the same thing. So if we want to integrate this blockchain to our existing application, we need to expertise in that blockchain things. Coming to the application, so we can list so many applications here. I have listed only some. So one is cryptocurrencies and financial service in the banking sector, or for developing a cryptocurrency like Bitcoin or Namecoin, we can use this blockchain technology. In the voting system, so by sitting at home, you can do the voting process without any illegal things. So there also we can use the blockchain. and intellectual property protection. So if I want to register for IPR for my work, I can go with this blockchain, right? And next is education. In the education sector also, we can use this blockchain for many applications, for providing loans or for providing content or for taking admissions, whatever it may be, right? So we have so many applications for blockchain. These are only few applications. So that is about blockchain technology. So in this video, we discussed about what is blockchain technology, what are the different consensus mechanism, different applications of blockchain, advantages of blockchain and disadvantages of blockchain. Thank you.